Right, today we've got two Olympiad style questions. The first one involves some 3D shapes within each other. So it reads the following. A cuboid box has height 10 and a square base of side length x. It is put in a cylindrical water tank with base a circle of area 360. The cuboid stays at the bottom when the water is added. So before we even start to read on, let's draw out our two shapes, our cuboid and our cylindrical water tank. So that's our cuboid with square base and a side length x, and then its height 10, and a tank with unknown height, but we know the area of its base. And let's read the following. When the box is in the tank of water with a square face against the bottom of the tank, the water reaches the top of the box. Let's go to point 1. When the box is in the tank of water with a non-square face against the bottom of the tank, the water level drops by 1. Let's call this part 2. The box is removed from the tank. How much further does the water level drop then? Let's work through this problem stage by stage. So let's visualize what happens in 1. So we've got our cylindrical water tank and our cuboid placed inside, and our water level. We've got a height of 10. Our shaded part is our water, and we've got a base of 360. And we want to find out what the water is. So another way we can look at this is by looking at this tank from a bird's eye view. So it's got square with x, side length x, and the rest of the circle is just water. So the water would be, the volume of the water would be our cross-sectional area, which is 360 minus x squared times the height, which is 10 in this scenario. Now if we go on to the second part, when the box is in the tank of water with a non-square face against the bottom of the tank, the water level drops by 1. So we've got a tank, except the box is on its long side. We've got height 9. We can draw the bird's eye view. We've got a rectangle with length 10 and x here. The volume of the water is 360 minus 10x times the height, which is 9. Now since we've got two equations for the volume of water, we can just equate them. 360 minus 10x times 9 equals 10 times 360 minus x squared. Well, we can divide both sides by 10, so we've got 9 times 36 minus 9x equals 360 minus x squared. We can rewrite 360 as 36 times 10. If we rearrange, we have, and bring everything to the left side, we got x squared minus 36 minus minus 9x equals 0. X squared minus 9x minus 36 equals 0. If you factorize, we have x minus 12 times x plus 3 equals 0. X equals 12. So now we know what x is. The last part of the question says that we need to find out how much further does the water level drop then. So when the box is removed, we've got water with height, let's say h. So we've got base 360 and we've got volume, well, we can use x equals 12 to find our volume. So water equals 360 minus 10x, where x is 12, all times by 9. 240 times 9, which equals 2160. We can form equation using the base, the height and the volume. So base times height equals volume. Where the base is 360, height is unknown, and the volume is 2160. Height equals 2160 divided by 360, which is 6. And we want the question asks how much has the height dropped from stage 2 up to the final stage. So we've got height 9 minus height 6 equals 3. That's how we solve this question. On to the next Olympiad problem. We've got m and n as positive integers, so elements of Z plus, such that m divides m plus 20 and n divides m plus 25. What is the maximum possible value of m plus n? Well, we can write m divides n as 20 as m, divide notation as n 20, and then n divides m plus 25. We can rewrite this where some scalar of m equals m plus 20, so m plus 20 equals km, m plus 25 equals pn, where k and p are positive integers. Now, since we want to find m plus n, we can sort of force an equation by finding the sum of our two equations 1 and 2. So 1 plus 2 equals m plus n plus 20 plus 25, which is 45, equals km plus pn. If we rearrange to collect all the m and the n terms, we get 5 equals km minus m, which is k minus 1 m, plus pn minus n, which is p minus 1 n. Now, we are trying to find the maximum possible value of m plus n. The way we do this is, if you rewrite out our new equation, we want to get this equation only in terms of either m and k or p and n. If we remove k minus 1m, we're left with 45 equals p minus 1n. The way we do this is by making k equal 1. So we're left with 45 equals 1 minus 1m plus p minus 1n. 45 equals p minus 1n. Right. Now, since we're trying to find the maximum value of n, we need the largest factor of 45 and the smallest factor of 45 timesing, where the smallest is p minus 1 and the largest is n. So if we quickly write down the factors of 45, factors of 45 are 1, 3, 5, 15, 9 and 45. So our largest factor is 45, and hence the smallest factor is 1. So p minus 1 can equal 1. P minus 1 can equal 1. N can equal 45, which means p equals 2. Now that we have a value for n, we can sub this back into one of our two original equations. So since we've got k, p and n, it's wise to sub into either, to be fair. So let's take our first one. N plus 20 equals km. So n is 45 plus 20 equals 1m. M equals 65. So for when k equals 1, we have m equals 65 and n equals 45. So here m plus n equals 110. However, this may not be our final answer, because we've considered the case only when k is 1. Now what happens when p equals 1? It's 1m plus p minus 1n. So when p equals 1, we have 45 equals k minus 1m. Using the same logic as before, m equals 45, k minus 1 equals 1, which means k equals 2. We've got m, k and p. Now let's use our second equation just to mix things up. M plus 25 equals Pn. M plus 25 equals Pn. So we've got 45 plus 25 equals 1n. N here equals 70. So m plus n, when we have p equal to 1, equals 70 plus 45 equals 115. Now our second case has a larger maximum value than our first case. 115 is obviously larger than 110, so we take 115 as our final answer. Thank you very much. Hope to see you in the next video.